Assalamualaikum and hi, my name is Nur Atasha binti Maho. So today our group will discuss about our group project for the subject QMT342, which is Queuing Theory Project at Mr. DIY. So first, let's go to the part 1.0, which is Introduction. So at this part, we will describe about the location, the operating time, the number of server, and also the observation time for our group project. So for the location, we choose Mr. DIY at Jalan Rambutan, Taman Sirah at Kluang. So standard operating time for Mr. DIY, which is from 10 a.m. until 10 p.m. The number of server during our observation is it's only one server, and for the observation time we take from 5 p.m. to 6 p.m. So now let's go to the part characteristic of queuing system. So for the 2.1, which is arrival characteristic, we will talk about the size of the calling population, the pattern of arrival at the system, and also the behavior of the arrival exits. So for the 2.1.1, which is the size of the calling population, we choose infinite population model, which is the amount of customer waiting and being served has no bearing on the arrival rate. So for the 2.1.2, which is the pattern arrival at the system, we choose the random arrival, which is follow Poisson distribution, which is lambda equals to 15 customer per hour. And then for the 2.1.3, which is the behavior of the arrival exits. Okay, so for the pattern customer, we say that the customer have to wait in the queue until they are being served. So for the 2.2, which is waiting line characteristic, the length of a line is described as since the arrival rate is unaffected by the number of customer in the line at the counter, the line length is infinite. So for the queue discipline, which is the way the queue is organized, Mr. DIY used a FIFO, known as first in, first out. She's the first customer who joined the line is the first to be served.
Next, there are three characteristics of service facility, which include number of channel, number of faces, and number of waiting time. For our case study at Mr. DIY, they are using single channel system with a single faces and single line. It means that from two counter, they open only one counter at particular time, and customers is queuing in one line because only one counter is open for them to pay. I think maybe at that time Mr. DIY is not busy, so they open one counter instead of two counters for customers to pay their things.
This diagram illustrates a single channel, single phase queuing model, commonly used to represent a simple service system. Here's what I can conclude. Firstly is a system description. So the arrival, individuals or entities enter the system, patient in a healthcare context. Queue, waiting area where arrival line up until the service facility becomes available. Service facility is a single point where service like dispensing and counseling are provided. Departure, one serve, the individuals leave the system. For the key characteristic, there is only one server, single channel, providing services. Each entity undergoes one stage of service, single phase. It operates sequentially when customer arrival, queue, service, and lastly, customer will exit. So, this model is useful for analyzing and optimizing waiting times and service efficiency in system with a single service provider. So this is data that we get from. So So firstly, we need to find lambda and mu. So the service time is equal to 47 minutes. So the average time equal to 47 over 15 equal to 3.13. Lambda is equal to 60 over 3.13 equal to 90.17. So what we can conclude that lambda equal to 50 customer per hour, mu is equal to 19.17 customer per hour. Characteristic of the selected queuing system. First, the average number of customer of unit in the system. Formula of L equal to lambda over mu minus lambda equal to 15 over 19.17 minus 15. We get it L equal to 3.6 customer. Second, the average number of customer in the queue. Formula of LQ equal to lambda square over mu bracket mu minus lambda equal to 15 square over 19.17 bracket 19.17 minus 15. So we got it LQ equal to 2.81 customers. Third, the average time a customer spent in the system. Formula of W equal to 1 over mu minus lambda equal to 1 over 19.17 minus 15. We got it W equal to 0.2 hour in minutes, 14.39 minutes. Lastly, the average time a customer spend waiting in the queue. So the formula WQ equal to lambda over mu bracket mu minus lambda equal to 15 over 90.17 bracket 19.17 minus 15. So we get it WQ is equal to 0.19 hour, or in minutes we get it 11.26 minutes. The table represents the result of an queuing system with the following observation. Arrival rate lambda is 15 customers per time units. Service rate mu is 19.17 customers per time unit. Number of server is 1. From the output, server utilization, the server is 28% utilized, meaning 28% of the time it is busy serving customer. Average number in the queue, LQ, there are 2.81 customer waiting in the queue on average. Average number in the system, L, there are 3.6 customer in the system on average. Average time in the queue, WQ, the customer spend an average of 0.19 time units in the queue. Average time in the system, W, the customer spend 0.24 time units in the entire system. The server is nearly fully utilized, 78%, which is efficient, but may lead to increased queue time if arrival rates increase. Average waiting time in the queue 0.19 time units and the system 0.24 time units are reasonable for current traffic. If demand increase, the system might require optimization or additionally server to maintain performance. So, what we can conclude from the output, these probabilities further demonstrate that the system is well performing but operating at a relatively high utilization level.
So for this part, I will explain to you guys about this table. So this table shows adding more server could improve queuing system at Mr. DIY. It is because, as we can see here, on the average server utilization, when we add more server, it will decrease. But once we add the server, we cannot add the server more than 4. This is because it will increase the cost in the system. As we can see at the 5th server, the average, the average on those average is the same, so it will waste. That's why the adding the server cannot be more than 4 servers. So from our observation, we can see that QA system at Mr. DIY is not quite efficient, as we still can add more server to improve it, but not more than 4 server.
Last, for the conclusion, based on this queuing theory, it can be evaluate the efficiency of customer service, pointing out strength and some part for them to improve. It also provide information on waiting times, service rate, and time between arrival of the customers. Last, the study is highlighted the importance in improving the quality of service toward customer satisfaction and operational efficiency. But for our case study, the queuing system at Mr. DIY is terribly efficient because we have to add more server to improve the system, but we cannot add more than 4 servers since it will affect the higher cost in the system. If we still add 5 servers, the average time has not changed, yet it is still costly.